We are doing 11.1, which is called definite integrals. And you'll see what I mean by this. This truly just is a recap or a summary of the stuff that we've been doing in 9.1 and 10.1 and 10.2. So when I saw this, I was looking through my notes, I thought I could have started with this first and done the other order, and or I could have attached this to one of those lessons. So it's going to be pretty straightforward. The first thing, I guess, is you didn't see definite written with integrals. So we talked a little bit about, like, we called them antiderivatives, and then we talked about how that's integrals. And then today we're looking at definite integrals. And we actually have already been working with those. You just didn't know that that's what they were. So just to sort of put this all together, there's two main branches of calculus. One is differential calculus. That's the stuff that we did chapters 1 to 9, derivative and tangent problems. And then integral calculus is chapter 10 and 11, which is area between curves and volumes of solids of revolution. We are likely not going to get to working too much with this stuff, but I think it's good for you to finish things off with a big picture perspective. So it's kind of a nice way to tie the whole course in for today and tomorrow. Okay, so then when we look at this, again, this is sort of old news. If we take a look at this portion that we have on the left here, the indefinite integral is solved by anti-differentiation. So that's the stuff that we started off with in chapter 9. It's represented by a function. So if I have the integral of f of x dx, we are at this point used to that notation, right? We know that it's equal to the definite integral that's going from A to point B. So the one on the left is an indefinite integral. Like you wouldn't normally say indefinite integral. It's just an integral. It's when we make it enclosed within a certain amount of space, between the upper limit and lower limit, as we've been working with. That's what we call the definite integral. So the definite integral is represented, I think this is missing stuff, represents the area enclosed between f of x and the x-axis between the endpoints A and B. So again, this isn't really anything new. We've been working with this. When we worked with it, we called B the upper limit and we called A the lower limit. And then to show a visual representation of what that would look like, we have this blue graph at the bottom. But again, that's the stuff that we've already been working with. So I guess the only thing about this idea of definite integrals and looking at the whole big picture of what all the chapters were, is just tying all the concepts together. But when you go to do this work for today, page 500, all these questions, you'll see it's sort of just review from stuff you've been working on. So that's really it for today.